So the next question we want to discuss from this diverse SDE sheet is the question number 4. That is the largest subarray with sum 0. So what the question states is we are given an array having both positive and negative integers. So there are both positive and negative integers in an array. The task is to compute the length of the largest subarray with sum 0. So we are given an array. We are given an array. So we are given an array. We have to compute the number of subarrays. We have to compute the length of the largest subarray. We have to compute the length of the largest subarray that has the sum equals to 0. So what we can do, so what is a subarray? Subarray is just the consecutive sequence of an array. So this is a subarray, this is a subarray, this is a subarray. So what approach we can follow is we can find all the subarrays that can be formed from this array, and we gonna compute its sum. If the sum equals to 0, we gonna say that we gonna find the length of the subarray that has the largest sum, that has the sum equals to 0 and have the length that have the largest length. We're going to return that length. Okay, so this approach will require order of n cube to find all the subarrays from the array, all the subarrays. Further we can optimize this to order of n square using two loops and find all the subarray sum and return the length of the subarray that have its subarray sum as 0 and have the maximum length. So is this our optimized approach? It is not an optimized approach because it requires a time complexity of order of n square. So can we solve it in linear time complexity? We'll try to do it. So what we'll do, so what's the optimal approach to solve the problem is that what is the intuition to solve the problem in a linear time complexity is, suppose for the current element we have find the prefix sum as y. Okay, let's suppose we are considering this subarray. Let's suppose its sum is y, and we have previously found the prefix sum as y. So what we can say that the sum of the elements that lie between this to this is 0. It's a simple math. If the prefix sum from the element is 0 to the fifth index, let's suppose it is y, and let us suppose the array element sum from the index 0 to 3 is also y. So what we can conclude is that the sum of the array elements that are from the index 3 to 5 is 0. So this is the basic intuition to solve this problem. So what we'll do, we'll maintain a hash map to store the prefix sum of the array elements. We'll maintain a hash map. We'll maintain a hash map. So we'll start iterating over the array and start comparing if our sum become equals to 0, or we have found the sum is previously stored in the hash map. So these are the basic conditions we're gonna check. So we're gonna at the current element our prefix sum is 5. We check if the sum is equals to 0. It is not equals to 0. If the sum is present in the hash map, no, our hash map is currently empty. So we're gonna store the prefix sum with its index in the array. So sum with the index, because we have to return the longest subarray, na? So we'll store the index. We'll move to the next element. Now our prefix sum become equals to 3. Is our sum equals to 0? No, it is not equals to 0. Is our sum present in the hash map? No, it is not present in the hash map because the current element that is present in the hash map is 3. Current sum is present in the hash map is 3. So what we're gonna do? We're gonna store the current sum with the index S1. We move to the next element, calculate the prefix sum. Our prefix sum is 5. Is 5 equals to 0? No, it is not equals to 0. Is sum 5 present in the hash map? Yes, sum 5 is present in the hash map. So what is the condition? This sum is equals to 5. This sum is equals to 5. So what we can say, that the sum of the element that is between this to this is 0. So what we can return, what we can let as suppose we are maintaining a answer vector that is initialized to length -1. We're gonna update it with the current index. Let's suppose it is I minus the index at which the sum is found, that is 0. So 2 minus 0 will update the length as 2. Basic. We again move to the next element. We do not update the index for the currently found sum because we have to find the longest now. So we do not update the 0 here. We do not update the prefix sum here. Okay. We move to the next element. What we have found? We have found the prefix sum as -3. Is -3 equals to 0? No, it is not equals to 0. Is that sum currently present in the hash map? No, it is not present in the hash map. So we will update it in the hash map with the current index. We'll move to the next element. Our prefix sum become equals to 2. Is it equals to 0? No, it is not equals to 0. Is this sum present in the hash map? No, it is not present in the hash map. We're gonna update it with the index. We again move to the next element. We again move to the next element. Our prefix sum become equals to 5. Our prefix sum become equals to 5. Is 5 present? If 5 equals to 0, no, it is not equals to 0. Is it present in the hash map? Yes, it is present in the hash map. So what we gonna update our condition, that this is 5 and this prefix sum is 5. So this is 0. So what we gonna update it with? At the current index, that is 5 minus the index at which we have found the prefix sum, that is 5 minus 0. So we're gonna update it with the maximum length. So our maximum length become equals to 5. We do not update the current sum because if the sum present in the hash map, we do not update it because we have to return the maximum of it in a maximum length. Then we move to the next element. Our prefix sum become equals to 15. Is 15 present? If 15 is equals to 0, no, it is not equals to 0. Is it present in the hash map? That prefix sum is present in the hash map? No, it is not present in the hash map. We're gonna update the hash map with the sum and the index at which it is found. Then we will move to the next element and find the prefix sum. It is equals to 38. Is 38 equals to 0? No, it is not equals to 0. It is present in the hash map? No, it is not present in the hash map. We're gonna store it with the index. We'll move to the next element. Our array is over and we're gonna return our answer as 5. So this approach requires a time complexity of order of n, majorly order of 2n, because we want to store the element in the, so sorry, we will require a time complexity of order of n, okay, and a space complexity of order of n to store the prefix sum. So we'll look at the code for this question. So I have previously submitted. We'll look at this code. Uh, so what we have done, we have used an unordered map. We have initialized our maximum length to 0. If the first element of the array is equals to 0, we will update it with maximum length with 1. We will start our loop from 0 and calculate the prefix sum. If the prefix sum become equals to 0, we're gonna update our maximum length. Okay. If the prefix sum is present in the hash map, we gonna update the maximum length. And if neither of the case, we're gonna update the hash map. So at the end, we're gonna return the maximum length. Okay. So this is the code. The code will be found in the GitHub repo. So if you have any doubt regarding the code or the explanation, please feel free to ask in the comments. Bye.